Good morning, Year 9. I hope you've had a good Easter break and had a rest and are ready to get back to some work. So we're starting today, this term, looking at a new topic, and we're going to be looking at probability. So we're going to start with the basics and then move on and learn some new skills. So our learning objectives today, we're going to look at understanding and applying the terms randomness, fairness and equally likely. And we're also going to look at calculating theoretical probabilities. Okay, now we finished last term looking at percentages, and we looked at one of the things that we did was we converted between fractions, decimals and percentages. Now that's a useful skill for our probability topic, so we're going to start with that. So if I scroll down, I've got a table here. So it would be good if you could copy that table and just fill in the equivalents. So if we've got the fraction half, what's the equivalent decimal and what's the equivalent percentage? So what I suggest you do is pause, copy that out and fill in the missing values, and I will put some answers up in a minute. So you should have your table filled in. So let's have a quick look. So if we've got a fraction half, then the decimal we should know is 0.5, the percentage is 50%. If I've got a decimal of 0.75, okay, the percentage is fairly easy, that's going to be 75%. But we also need to know that 75% or 75 out of 100 can be cancelled to 3/4. If I've got 25%, then the decimal is 0.25, and again 25% is 25 out of 100, and that can be cancelled to 1/4. Now this one's slightly harder, a third. So the equivalent decimal to a third is actually 0.3 recurring. It's not 0.3, okay? So 0.3 would be wrong. You have to write it as 0.33333333 with some dots, or you could write it with, I'll do it over here in pen actually. You could write it as no good. Try again. You could write it as 0.3 with a dot over the 3, but you must have a very clear dot on the 3, okay, because that is the same as this. Okay, now if I multiply that number by 100 to get the percentage would come out as 33.3%. So 33.333% you could write that as 33 1/3, because we know 0.3 recurring is a third, so it will be 33 1/3%. So either of those, but again you have to have the recurring part for the decimal. So 0.6, if I multiply that by 100, I get 60%, okay? 60% is 60 out of 100, which cancels to 3/5. If I start with 40%, that divided by 100 is 0.4, and 40% is 40 out of 100, which cancels to 2/5. So hopefully you got those right. Other ones to think about that are recurring decimals are things like 1/6 and 2/3 as well, so just be wary of those. Okay, let's have a look. So we're going to look at some games. I've got a PowerPoint that I will just pop up here. And we're playing a game. So you would throw a coin onto a board, and if it lands on a shaded square, you would win. Okay, so assume the coin always lands exactly in a square. So we're not interested in it landing half and half. It either lands on a blue square or it lands on a white square. So if this was the board here, would this be a fair game? So have a think and think about how you know whether it's fair or not. Okay, what if it landed on this board? Would that be a fair game or not? So you might want to pause the video to think about that one. And again, what about this one? Would it be fair or not? So just have a pause and think. Okay, so if we have a look at the first one, if you counted up, you'd see there are 16 squares. And for it to be fair, okay, what you'd want is to have an equal number of squares where you'd win or lose. So I'd want 8 blue squares, 8 white squares. Well, we can see I've only got 6 blue squares here, so that's not going to be fair. Okay, similarly here, we've got 20 squares in total. Okay, so again, I'm looking for 10 and 10 for win and lose. So I've got 2, 4, 8, 9, 10, 11. So you are more likely to win than to lose on that one. Okay, so if you're playing against somebody else on this game, okay, the person who landed on the blue or who scored with blue was more likely to win than the person who scored with white. So again, that's not a fair game. On this one, oops, let's go back a stripe, sorry. There are 32 squares, and so you'd want 16 blue. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 there. So 16 blue, 16 white. This is a fair game. So it's equal chance of getting blue and white. Okay, let's have a look at this one. So this one, we've got a marble is picked from a container by the teacher. If it's red, the girls get a point. If it's blue, the boys get a point. So again, is this going to be fair? So in other words, we're looking again for equal numbers of red and blue, and we can see there are 4 red, but there are 5 blue. So the boys here are at an advantage. If we look at the next one, again, we want equal numbers. I've got 6 red, I've got 6 blue, so that would be fair. This one, I've got 1, 2, 3, 4, 5, 6 blue, but I've got 2, 4, 5, 6, 7 red. So here, the girls are at an advantage. Okay, so I've got 9 cards numbered 1 to 9, and we draw 1 card at random. Okay, so the rules are, if a multiple of 3 is drawn, Team A gets a point. So remember, multiples of 3 are numbers in the 3 times table. If a square number is drawn, Team B gets a point. So if you remember, square numbers are a number times by itself. So 1 times 1, which is 1, 2 times 2, which is 4, so 4 is a square number, 3 times 3, which is 9, so 9 is a square number. And any other number drawn, Team C gets a point. So just pause and have a think. Is that a fair game? Or can A, B and C, are they equally likely to win? Okay, so let's have a look then. So Team A gets a point when we get multiples of 3. So there are 3, 6, 9. There are 3 opportunities out of the 9 cards for Team A to get a point. Team B gets a point for a square number. So the square numbers are 1, 4 and 9. So again, there are 3 possible cards where Team B would get a point. So at the moment, A and B are equally likely to win. They've both got 3 cards that they could possibly get points with. And if it's any other number, Team C gets a point. So Team C wouldn't get a point with 1 because that belongs to Team B. 2, Team C would get a point. Okay, 3, no. 4, no. 5, yes. So that's 2 cards so far, 2 and 5. 6, no. 7, yes. 8, yes. 9, no. So actually there are 4 cards where Team C would get a point. Okay, so Team C is more likely to win than A and B because it's got 4 cards that it can get points on, whereas A and B have only got 3 cards, so that's not a fair game. Here we've got a spinner. So we've got 5 equal sectors, okay, so that means the arrow is equally likely to land on any one of those, okay. So if the spinner stops on an even number, team A gets 3 points. And if the spinner stops on an odd number, team B gets 2 points. So have a think, is this fair? Okay, so let's have a look. So for A, we need it to land on an even number. Now there are 1, 2 even numbers, okay. But every time it lands on a 2, they'll get 3 points, and every time it lands on a 4, they'll get 3 points. Okay, so there's a possibility of 6 points available here. Okay. Now, team B gets points when the spinner lands on an odd number. Now there are more odd numbers, so 1, 3, 5. So it looks like team B has a higher chance of winning. Now it has a higher, it's more likely to land on those odd numbers, but team B get fewer points. Okay, so if we add that up, there's 2 points for 5, 2 points for 1, 2 points for 3. They've also got an opportunity of getting 6 points. So actually it is a fair game. So although the team A only have 2 possible numbers, team B have 3 possible numbers, it's evened out by the number of points that are scored each time. So that was an interesting one to think about. Okay, so that's the end of that slide. So I can just come out of there. Okay, so we've had a think about fairness, okay, what makes games fair or not. Okay, we're now going to move on to how we work out our probabilities. All right, so I talked a lot in the previous one about having equal numbers or having 3 cards out of 9. So, probabilities. So a probability is a measure of how likely something is to happen. Okay, so we'll think about chances is another word that we often use for probability. Now, for our GCSE exams, probabilities are written as fractions or decimals. So a lot of the time we will write probabilities of fractions. Okay, but they can also be written as decimals. Now, GCSE exams, they don't like them written as percentages, and you certainly wouldn't write them as ratios. So just make a note really that we need to write probabilities as fractions or decimals. Percentages are okay sometimes, but we tend to in exams stick with fractions or decimals. So if you could get that into your notes. Okay, so pause if you want to. The other things we need to know about probabilities. So probabilities are written as numbers between 0 and 1. You can't have a probability greater than 1. You can't have a probability less than 0. So what do they mean? A probability of 1 means that the event is certain to happen, and the probability of 0 means the event is impossible. Okay, so we'll look at some examples of those in a minute, but if you can again get those into your notes. You may have come across that before, but we're just covering the basics. Okay, so how do we calculate probabilities? So we've talked about theoretical probability. So theoretical probability means it's what should happen. It's not what will happen, okay? It's what we would expect to happen. So for example, if we were throwing a dice, we could get a 1, a 2, a 3, a 4, or 5, or a 6. And we would expect, because there's one of each, and if the dice isn't biased, that they would come up equally. But we know that when we throw a dice, if we threw a dice 6 times, we know we wouldn't get a 1, a 2, a 3, a 4, or 5, or 6. We'd get maybe, you might even get 5 6s, or you might get 2 3s. So it's not what will happen, it's what we would expect to theoretically happen. Okay, so how do we work that out? So theoretical probability is the number of favourable outcomes, so the thing that we're interested in, out of the total possible number of outcomes. So it comes out as a fraction. Okay, so if we look at this example here, I've got a bag, and in my bag I had some red and green counters. Okay, so I can see I've got 4 green and I've got 6 red. So for example, if I was looking at the probability of, if I put all those counters into my bag, okay, oops, let's get them in the bag. Okay, now if I wanted to draw a counter out, okay, I've got an equal chance there of pulling any one counter out. There's no reason why I should pull out one rather than the other. If I'm looking at the probability of pulling a green counter out, I need to think about how many green counters there were, okay, out of the total number of counters there were. So the favourable outcome is the green counters, and the total number of outcomes is the total number of outcomes. So if you remember, we had 4 green out of a total of 10. Okay, so I'm going to leave that as 4/10 now. Okay, most of you will see that we could cancel that, but I'm not going to worry too much about that now. Okay, that probability is 4/10. So the probability of a red counter, okay, is the number of red counters out of the total number. So we knew there were 6 red counters out of 10 counters altogether. Okay, so that's what a theoretical probability is. Okay, on a dice, okay, here's my dice that I can spin. Okay, so what's the probability that I get a 2 on a dice? Well, we need to think about how many 2s are there on a dice. Well, there is only 1 2 on a dice, so that's going to go on the top. Okay, but how many numbers are there on a dice? Well, there are 6 different numbers on a dice, so it's 1 out of 6 is the probability. Different probability is, what's the probability I get an odd number on the dice? Okay, well, we need to think about how many odd numbers there are on the dice. Well, there's a 1, a 3 and a 5, so there are 3 odd numbers, that's our favourable outcome, out of a total of 6 numbers, so 3 out of 6. And remember, because it's a fraction, we can cancel it, so 3 out of 6 is a half. So the probability I get an odd number is a half. Okay, I want to have a think about this question now. Okay, so here's my dice again. Is it going to spin? No, it is. There we go. That's my spinning dice. Okay. What's the probability that I get a 0? Have a think about that. What's the probability I get a 7? And what's the probability I get a 1 or a 2 or a 3 or a 4 or a 5 or a 6? So, hopefully, you'll have worked out that actually it's impossible to get a 0 on the dice. And we said earlier on, the probability number that stands for impossible is 0. So we're not using words anymore, we are using numbers for probabilities. So if we've got an impossible event, the probability is 0. What's the probability I get a 7 on a dice? Well, again, there are no 7s on a dice, so that's an impossible event. So again, that probability is 0. Now, what's the probability I either get a 1 or a 2 or a 3 or a 4 or a 5 or a 6? Okay, well, I could definitely get a 1, because there's 1 on there. I could definitely get a 2 or a 3 or a 5 or a 6. There's nothing else I can get. I am definitely going to get one of those numbers. So that's a certainty. Okay, I'm definitely going to get one of those numbers when I throw a normal dice. So that probability is 1. Okay, I'm going to get one of those numbers. Okay, so this is the example of impossible events, a 0 or a 7, and certain events, a 1, 2, 3, 4, 5 or 6. Okay, so what we've got here is some questions for you to have a go at. Okay, pause, answer the questions. Okay, there's a couple more further down. Okay, have a go at those questions. Okay, so you can send me the work that you do, but what we'll do is I will put the solutions, the answers at the beginning of the next video, so you can mark when we get to the next video. Okay? Okay.